In this video, we're going to look at a very important topic in computer science. It's the topic of abstraction. And we're going to couple that with beginning to think about how we can work with multiple classes when we're building a program. So thus far, we've really focused on single class projects like the ticket machine. And we've looked at the fundamental pieces of source code, such as fields, constructors, and methods. So now it's time to think about how we might build more complex applications and how we deal with some of the issues of complexity that arise when we start becoming more ambitious in the kind of things that we want to write. For instance, we might be interested in writing a program that can play audio files. And in fact, this is something that we look at in Chapter 4 of the Objects First with Java textbook. Faced with such a complex task, that may seem insurmountable given what we know about programming in Java so far. So how might we go about writing something like that? And it's this idea of tackling complexity that we're going to start thinking about in this video. The particular program that we're going to think about how to write is something like this. It's a 24-hour clock that keeps track of what the current time is in terms of how many hours, how many minutes, and how many seconds. And we're going to think about how we might design something like this from scratch. What do we need in terms of Java source code? What are our classes going to look like? How do we manage the potential complexity that arises from writing something like this? And the kind of lessons that we'll learn from looking at a solution to this problem will be things that we can then build on as we tackle more and more complex problems throughout this course. So the actual problem we're going to look at is a simplified version of that 24-hour clock that we've just seen. We're really just going to focus on how we keep track of the number of hours, the number of minutes that represent the current time. And even though this is a simplified version of the one we've just seen, we could extend it very easily to fulfill the requirements of hours, minutes, and seconds. So given a problem, any problem, how do we actually go about breaking that problem down and thinking about how we're going to solve it? So what we typically do is make use of something called abstraction. And abstraction is a really pervasive concept throughout computer science. You'll meet it over and over again, not just in the realm of programming, but in lots of other areas of computer science if you're studying those. So in a simplified form, abstraction is the ability to ignore detail in the overall problem in order to focus our attention on a higher level of the problem. In other words, to suppress some of the detail that exists in a problem so we can devote our energies to solving a relatively small section. And if we keep on doing that, then gradually we solve individual pieces of the overall problem. We put those pieces together and ultimately we've managed to solve the whole problem. There's another side to abstraction in addition to this idea of ignoring detail, and that is the identification of common features in a problem in order to create generic representations that help us solve the problem. And you'll see what I mean by that as we start to explore the clock display problem. Now, related to abstraction is the idea of modularization. If what we're going to do is to hide or suppress detail and focus on individual elements of an overall problem, but break a problem into multiple small parts, then we need a mechanism that will allow us to group together related bits of the problem that we're solving, and modularization is one way that we do that. So it's the process of dividing a whole into well-defined parts which we can then examine and build and test separately before we put them all together. And classes are one particular way in an object-oriented environment that support modularization. They allow us to group together related functionality in a single class and then make use of that class as part of the overall problem that we're solving. And something that we haven't touched on yet, but we'll meet later on, is the idea of a Java package. And a Java package is a way of grouping together related classes into a module-like form, and then that package can be used as a single unit, again as part of solving an overall more complex problem. So let's look at how modularization might apply in the context of the clock project. So you've seen the clock in action, and one way to think of that clock is as a single 4-digit display or a single 6-digit display if we're also managing the seconds. So we could consider implementing the whole solution as a single class with, let's say, a few integer fields to store hours, minutes and seconds and so on. But there's another way of actually looking at this, and that's to say that it actually consists of an hours display and a minutes display and potentially a seconds display. And if we think about the way in which hours and minutes work, they work in a very similar fashion. Over the course of 24 hours, the hours start at 0, work their way up to 23, and then wrap around to 0 again. And over the course of a single hour, the minutes start at 0, they work their way up to 59, and then they wrap around to 0 again. So abstraction allows us to characterize hours and minutes, the behavior of hours and minutes, as a kind of a bounded counter idea. So this idea that we somehow want a counter that gradually increases, but when it hits a limit, it wraps back around to 0 and then carries on incrementing until it hits the limit again, and then it wraps around to 0. And that bounded counter idea would apply both to hours, to minutes, and to seconds. So one way of thinking about our clock is to think of it as being two of these bounded counters, each one of which is individually managing either a number of hours or a number of minutes. And then our overall solution to the clock problem is to have two of these bounded counter objects, and we manage those two together in some way, so that as each 60 minutes expires, then the next hour is moved on to, potentially wrapping around at midnight. So we've got this abstraction that arises from thinking about what the components of a 24-hour clock might be, this idea of a bounded counter or a wraparound counter. And in fact, the approach we're going to take in developing the solution is to create a class that implements that idea of a bounded or wraparound counter, and then compose two of those together in order to implement our overall clock mechanism. And we're using two of these for hours and minutes. We could easily add a third if we want both hours and minutes and seconds. So we're going to define a class that we're going to call number display. And the functionality of our numbers display class is going to be such that it's going to store a current value, such as what hour is it, what minute is it, and then a limit for that value, either 24 for the hours or 60 for the minutes. And as each minute passes, then the number display will receive an external signal, and that will allow it to increment its value, checking all the time to see whether it's reached the limit. And if it has reached the limit, then rather than setting its value to the limit, it wraps around to 0 at that point. So probably the best way to illustrate this is to look at the source code for the number display class. So here is the number display class, and what you'll come to realize is that there's nothing in this class that you haven't already met before in the material that we covered in chapter 2 of the textbook. So it uses simple fields, a basic constructor that initializes those fields, and some methods that operate on those fields or return their values. So here we have a field whose value is going to represent the limit for the wraparound counter. So if a particular number display object were being used for hours, then we would store the value 24 into the limit, and we have a field to store the current value. So what hour is it? Is it hour 0, 1, 2, 3, and so on? And we will guarantee through the implementation of this class that that value will always be in the range 0 to 1 less than the limit. It will never actually take on a value that's greater than or equal to the limit value, and that's something that we want to maintain as what we call an invariant for the class. So we have two fields. We look down to the constructor for initialization of those fields, and we see that that's there, and the constructor takes a parameter that tells a particular instance what's the limit value for this instance. For instance, 24 for an hour's instance, or 60 for a minute's instance. And the value of that parameter is then stored into the limit field here, and then we assume that the value is starting at 0. We could easily arrange for a second constructor to be added that would allow both the rollover limit and the current value to be set if we needed to. We then have an accessor method for the value. We then make use of string concatenation in the getDisplayValue method. So what this is going to do is return a 2-digit string for every possible value within the legal range of a particular number display object. So because values in the range 0 through to 9 are only a single digit, if the current value is less than 10, then in order to return a 2-digit string, we need to use string concatenation to prefix a leading 0 in front of the single digit that's in the value. On the other hand, if the value is greater than or equal to 10, so it's already 2 digits, then we need to return a string for that 2-digit integer value. Now we can't simply return value. If we were to do that, then we would be returning an int when the return type from this method is a string, and we can't do that. The compiler can't recognize that it should be turning the int into a string in order to match the return type. So we have to artificially concatenate an empty string onto the front of the integer value in order for integer conversion to happen to string. So this is a little tricky device to turn an integer into a string in those circumstances where we need it. Here we have a mutator method for the current value. So if we do need to set the clock's display to some particular time at any point, then we pass in a parameter. We're very careful to make sure that that parameter value matches the requirements of the object, that the value only exists within the range 0 to 1 less than the limit of this particular number display object. So we have an if statement that says only if the incoming value is both greater than or equal to 0 and strictly less than the limit value do we allow the change to be made to the value instance variable. So this is a protective mutator method that only makes the change if it's satisfied that the change would fit with the requirements or the contract or the invariant of the class, that the value field always lies in the range 0 to 1 less than the limit. And then finally we have a method that allows us to add 1 to the current value, again respecting the fact that it must never actually take on the value of limit. It's going to have to wrap around if that were ever the case. So we increment value, and then we see whether that increment has led to value becoming equal to the limit, and if it has, then we are required to set the value back to 0. In all other circumstances, we simply leave the incremented value unchanged. So this is our increment method. In a later video, we'll actually talk about an operator that exists within the Java language that allows us to considerably simplify the body of this method, and that's an operator called the modulus operator. But we'll look at that in more detail another time. So now that we have a number display class whose implementation allows us to model this idea of a wraparound counter starting at 0 and going up to 1 less than some limit, how can we make use of that in the implementation of the overall clock or clock display class? We can now build a new class out of two instances of our number display class. So here again we see a standard class definition. We've got a class header for clock display, but the distinctive feature we've got now is that the data type of the two fields is not one of the standard types such as int or boolean or double. The type is number display. In effect, what we've done by defining a number display class is introduce a new data type into the language. And because we have a new data type, we can then define variables to be of that data type. So we've got a field called hours of type number display and a field called minutes of type number display. So what we're introducing is this idea of classes as types. So every class is a unique data type. Ticket machine, number display, string, whatever it might be. And once we've introduced a new class, we can then declare variables of that type. Now, the fact that clock display depends upon number display to provide its functionality is shown within the class diagram within BlueJ by an arrow going from clock display to number display. So that tells us that the implementation of clock display is dependent upon the implementation of number display. So this is a visualization, if you like, of abstraction, that in implementing a clock display, we're going to hide away the details of how those individual minutes and hours are counted in the definition of a separate class. And so then when it comes to implementing the functionality of the overall clock, in other words, we're going to combine hours and minutes and potentially seconds, then clock display doesn't have to worry about the details of how minutes and hours are incremented and wrapped around. That's all abstracted away and hidden inside the number display class. So the class diagram tells us that the clock display class depends upon the number display class. The number display class provides it with functionality in order to enable it to fulfill the overall task. Now what the class diagram gives is what we call a static or a compile time view of the relationship between these two classes. It doesn't tell us anything about how many instances of the number display class might be in existence for every instance of a clock display class. So if we want to gain further insights into what's going on at runtime, in other words, get a dynamic view of the program and the relationship between these classes, then we would look to what we call an object diagram. So the object diagram gives us a snapshot of what's going on at runtime inside the memory of the machine that's executing a clock display program. And this tells us that every clock display object actually makes use of two number display objects in order to maintain a display of the number of hours and the number of minutes. And obviously, if we wanted also to record the number of seconds as well, then there would be three number display objects in this diagram, so that at runtime, one clock display object is interacting with or dependent upon three number display objects. Now, notice that we represent that interaction between the clock display and the number display via arrows in the diagram. And this is also reflected in what you would see in the object inspector. If you create a clock display object and open up the inspector, you now don't see numerical values or Boolean values inside the value area of the instance variables. You would now see arrows to indicate that those instance variables are not storing what we might call low-level values like numbers. They are storing what are called object references. In other words, references to an object. So we use arrows as a visualization of an association between two objects, and because two objects have an association, those objects can interact with one another. And in a later video, we'll look at how objects interact with each other. So this idea of an object reference is a very important one, and it's something that we'll come back to many times as we work on through the material here. So we've seen that a clock display class is defined in terms of number display fields. Let's take a look at the constructor, because we always look to the constructor to see the initialization of its fields. A very important point to take away from this discussion is that a field itself is not an object. A field defines a variable, and that variable is able to store a reference to an object of the field's type. So writing private number display hours does not mean that a number display object gets created at that point. The creation of those objects, hours and minutes, happens inside the constructor here. In order to create an object, we always need to say new and then the type of object we want to create. So inside the body of the constructor, we indeed see two statements: the creation of one number display object to store the hours and another number display object for the minutes. Notice that in creating the number display objects, we need to tell those objects what their limit is, and it's a different limit for each of those objects depending upon whether one is looking after the hours or one is looking after the minutes. So you might recall from a previous video that it's useful to have bits of terminology that describe how we refer to the parameter value in the caller and the parameter in the receiver. So inside the clock displays constructor, that numerical value 24 we call the actual parameter, and in the source code for the number display class, the named parameter, rollover limit in this case, is what we call the formal parameter. So when new number display is executed, that actual parameter value is copied into the formal parameter variable, and then that variable can be used inside the body of the constructor in order to set the limit of that particular number display object. If we drill down a little bit further in the objects that are coming into existence when a clock display object is created, we can see now that those two number display objects are storing a limit value and a current value. So this represents the time 15:23. And the number display object for the hours has a limit of 24, and the number display object for the minutes has a limit of 60. Now, you might wonder how this maps into the underlying memory of the computer at runtime, and the next slide attempts to visualize that a little bit for you. Don't worry too much if this particular imagery doesn't work for you or you can't relate to it, but it's an attempt just to drill down a little bit lower in the implementation of the way that objects work within the Java memory. So we can think of the clock display object as being stored in a block of memory locations, if you like. And two of those memory locations will actually be references to other areas of memory which are being used to store the data values for the two number display objects. So at the top, I've grouped together hours and minutes, and hours and minutes don't actually store numbers, they store references to other areas in memory where the object details for the other two number display objects are. So the middle red section represents the minutes number display with a value of 23 and a limit of 60, and the lower red area is the number display for hours where the current hour is 15 and the limit for hours is 24. So this is attempting to give you a low-level view of what's represented here in this higher level object diagram. But don't worry too much if this doesn't really explain to you how things work at a lower level. So let's review what we've talked about in this video. We make use of abstraction in particular because it allows us to manage complexity when we're trying to solve a potentially large problem. So it allows us to focus separately on individual parts so that we can then piece those parts together gradually to solve the overall problem. And this idea of breaking up a large problem into smaller parts and really focusing on subparts of the overall problem is a technique known as divide and conquer. And that, again, is a computer science technique that's used in lots of other areas as well as this kind of problem-solving area. We've seen that each class that we define introduces a new type, and therefore we can use classes to help us define higher level classes. So we can think of the number display as being a relatively low level class that allows us to create a higher level class, a class at a higher level of abstraction in the form of the number display class. So those lower level classes reduces the complexity of the higher level classes. And then a particularly important point is that a variable of class type, such as hours or minutes, stores a reference to an object of that type. It doesn't store numerical values or Boolean values, it stores an object reference. And the concept of object reference will be important throughout this course.